Hi everyone, my name is Yueqi. Today I'm here to introduce a project on Beyond Browsing API-based web agents. This is a joint work with Frank Shui and Graham from CMU. So what are web tasks? Let me first introduce the web task first. Um, One famous benchmark on web tests is named Web Arena, where an example test would be create an efficient itinerary to visit all of Pittsburgh's art museum with minimal driving distance starting from Stanley Park. This might be a difficult examples, but there are other simpler examples. For example, create a new repository on GitLab with the name AI agents, and show me the route from CMU to U Pittsburgh. These are some example of the web arena web tasks. So existing web agents typically operate within the space of graphical user interfaces, which are abbreviated as GUIs. And these action spaces often simulate human-like keyboard and mouse operations, such as clicking and typing. For example, here, um, sorry. For example, here, this is a simulated website where the agents could add items to the shopping cart and perform shopping actions. Then the inherent GUI for this website might look like something in the middle and right image part of the image, um, where it's based on accessibility trees. Let's see a real-world example on how the agent acts with this GUI. So, for example, this is a task related to GitLab where the agent is asked to set up a new empty repository with the name awesome LLM reading. And first, the agent noticed that there's a create new link on the page. Like this is the region that it's clicking. And after clicking this, it will went to another page of creating a new project. And then it noticed that the most appropriate one is create a new blank project, like the top left corner one. And upon clicking, it shows the page of creating blank project. And then it types in awesome reading in the project name and create a project. So now there shows a new blank project named awesome reading. Um, this is how the agent creates finish this task on GitLab. So this leads to a new research question. Is simulating human behavior the most optimal solution for web agents? Because like web agents use browsers as an interface to facilitate humans in performing daily tasks such as online shopping, online planning, trip planning, and other work-related tasks, but they are often kind of complex. Then this leads to a question, should we like simulate human behaviors when designing web agents? Um, This lead to analogy of birds and planes. Like in looking upon our history of flying to the sky, we didn't mimic birds to fly into the sky, but we use aerodynamics such as building planes to fly into the sky. So this might lead to agent design of we shouldn't mimic like human behaviors when designing web agents, but instead we should combine like, for example, birds have wings and aerodynamics together to design web agents. Let's first look at a baseline browsing agent. A baseline browsing agent could, for example, based upon the Open Hands framework, operates based on the accessibility tree structure that I just mentioned, and it can navigate through arbitrary web pages, but it performs only well on simpler layouts. This is the structure of the browsing agent, where it first takes in user input, and the agent can perform the tasks through web browsing, and it looks at the accessibility tree structure, and see where to click, where to type, where to operate, and then like based on this task completion, it gives the feedback to the user again. But there are some inherent challenges with the browsing agent. For example, the complexity of accessibility tree structures. Let's see an example of the accessibility tree structure. This is accessibility tree of the GitLab web page where to log in, you need to first click the text box username here and enter the username and then click the password and enter the password and then click login. This takes like 5 actions for the agent to slowly log in. Not to mention like later other more complex actions of completing the task. Other than that, many LLMs today are not very familiar with GUIs. For example, Llama is now trained on accessibility tree structures. And they often struggle with content that need to be dynamically loaded or content immediately visible within the tree. Let's see a few examples of the browsing agent. For example, given the task, how many comments did the user set tag as make to A11 project the REPL? The browsing agent need to first go to GitLab and log in with the credentials, click the A11Y project, and then click repository, click commits, and if found no commits, and just scroll down, and no commits left, and no commits find. Like for each task, the agent will be given a limited number of steps because like if we give unlimited number of steps, the final cost might be very high. So given this limited number of steps, it cannot like complete the task successfully. On the other hand, the API calling approach offers a direct interface for machines to communicate with web services, which can reduce operational complexity. I know many people are already familiar with the concept of APIs, but let me just give a brief introduction. APIs are predefined endpoints for efficient task completion. It uses standard protocols like REST. It enables interactions via HTTP requests like GET, POST, and PUT, and returns structured data such as JSON objects. For example, let's see an example of the API GET API ID commits. First, where to obtain APIs and documentations. For the Vibrina benchmarks, we obtained the APIs and documentations from the website's public API documentations. For example, like for the shopping task, we use this link to obtain APIs. But sometimes if the API documentation is not available, then we can generate documentation via LLMs like GPT-4o. Like given the implementation of the APIs, GPT-4o can give a reasonable level of documentation of the APIs, like how to use the APIs. Let's see an example of the API documentation. This is an example from GitLab where the API is designed to get a list of commits in a given project, and it will show very specifically the input parameters, for example, the ID, and another 2 optional parameters, since and until, that have their own functionalities of retrieving commits based on a fixed date. And it will also give an example output JSON containing all the commits that meet the given criteria. Like for example, if I want to retrieve the commits from the repository, let's say AI agents, then like I need to put ID equals AI agents and to retrieve the commits. This is an example API calling approach where we can use Python to with a request library with a simple one function call. This will retrieve all the commits of the A11Y project from GitLab. This is an example of an API calling response. It will give a JSON output with all the commits listed in the repository. So this leads to a question. What if we were to take tasks traditionally tackled by browsing agents and give AI agents access to APIs? This leads to the new agent design of API-based agent where The structure is that the agent takes in user input and perform tasks by API calling and coding, um, specifically more in Python than the other languages. And then like based on the output of the API calls and code, it will give the response to the user. This is an example API calling approach to solve a task, like the same task with the web browsing example task. Um, the task is like find the number of commits the user subtag as made to the project A11Y project. And then like this is the approach where I mentioned previously on like using the browsing agent to complete a task. Well, using an API-based agent, on the other hand, will only require 3 steps, where um, the browsing agent requires more than 15 steps. Like here, in the 3 steps, it will first call the API GitLab, API in GitLab that retrieve the commits from A11Y project, and then convert it to a JSON file, and then it will just check like how many commits are there that has the author name that matching subtag as. So this only like uses 3 steps to complete the task, which is very simple. Um, Now like if the API agent is just so efficient, then given the benefits of API calling, should we just like not use web browsing after all? Um, let's first look at error distribution of 100 randomly sampled tasks from the API calling agent. So these are from the WebArena benchmark, where we can see among these 100 tasks, 50% of the tasks are unsolvable. So like it's unsolvable solely with APIs. This is because APIs might not cover all potential use cases, because like there might be corner cases that the API designers did not like come across when designing the APIs. And then like among the 50% of the solvable tasks with APIs, like 33% are correct, 11% are wrong due to API usage, and 6% are wrong due to task understanding. We can see that like this means that among the solvable tasks, the API-based approach could solve like 66% of all the tasks among the solvable tasks, and its error rate is much lower than the browsing agent. But with the 50% unsolvable task, it's still like worth considering another approach that could like solve that could mitigate this 50% unsolvable task. Um, So this leads us to think about the limitations of API calling. First, not all websites provide comprehensive API support. Um, we have more details on this in our paper, but to summarize, some websites have very good API support. Like for example, for the GitLab website, it has almost 1,000 APIs supported, and the API documentation is really good. So the agents could be able to solve most of the tasks using the APIs provided in GitLab. But this might not be the case for other websites where the API is not like very comprehensive enough to solve all the tasks on WebArena. And other than that, not all websites provide good API documentation. Um, for example, there's no API documentations available for Amazon Shopping. And to solve this, there's a potential future solution of using automatically generating APIs for unsupported tasks, which will reduce reliance on manual API creation. And there's also complexity in adapting to new website. For example, as I mentioned previously, we obtain the API documentations from the websites of WebArena like manually. So we downloaded the API documentation from WebArena websites. This makes it like more difficult to adapt to other new websites as compared to the web browsing approach, because the web browsing approach can like browse any websites like granted access. But for the API calling approach, we need to provide the agent the API documentations in order for it to like use API calling to solve the task. And as a potential future solution, we might be able to automate API scraping and documentation generation such that this will not be a problem anymore. Another solution, like to solve this limitation of API calling, is a hybrid agent where it integrates both browsing-based and API-based agents and is capable of interleaving browsing and API calling actions. So in each step, the hybrid agent could choose between communicating with humans in natural language to ask for clarification or confirmation, generate and executes Python code which could include performing API calling, and perform web browsing actions. So like to perform one task, it has, for example, let's say 15 steps to complete a task. Then in each of the step, it could either do API calling or web browsing. So it can integrate both approaches to complete one task. This this agent choose the action based on API quality. For example, if it think that the next step is better be done with with the API calling approach, then it will perform the API calling approach. And if it thinks the next step is best completed using a web browsing approach, then you can choose the web browsing approach. So it's totally based on the agent itself. And in this case, the hybrid agent can leverage the strengths of both API-based calling and web browsing. This is the structure of the hybrid agent, where it takes in user input first and can perform API calling and web browsing iteratively to complete the task. For experiments, we use the WebArena benchmark and the OpenHands agent framework to perform the experiments on the API-based agent and the browsing agent and the hybrid agent. So this is the agent performances. We can see that in most of the websites, the API-based approach outperform the browsing approach, and the hybrid approach outperform like both. Um, we also achieved the highest performance among task agnostic agents like on WebArena. Um, for example, here we can see that for websites with good API documentation like GitLab and Map, the API-based and the hybrid approach like outperform the web browsing approach like by a very high percent. But for websites with less number of APIs or lower quality API documentation, like for example, the Reddit website, um, like the difference is not as significant as the difference in GitLab and Map. This leads us to wonder, like, does API quality matter? First, API quality does significantly impact the performance of the API-based agent. This might be very obvious, but um, for example, for GitLab and the Map, the API-based agent performance is very high, and for Shopee and Shopee in the Mean, which has like fair level of APIs and API documentation, it has like medium performance on WebArena task. For the Reddit one, it has like very low number of endpoints and the quality of the API is very low. Then the Reddit one has lower performance with the API-based approach. And we also did some experiment with Reddit by manually incorporating more number of APIs. Originally, there was only like 18 endpoints available on Reddit, where the API-based agent only achieved a 9.4% accuracy on Reddit. But after manually introducing more, 15 more 13 more endpoints, the accuracy raised to 18.9%. Um, we didn't like added the APIs based on the WebArena task, but instead we like mimic the actual Reddit websites like functionality to implement this endpoint. We also performed some case study to see how different the hybrid agent and the API-based agent and the web browsing agent is when performing real web tests. For example, given the task of deleting all negative reviews for a particular item from the shopping website, a web browsing agent will first log into the shopping website's URL and log in with the credentials, and it performs like many steps because the task is very complicated. Um, However, the API calling approach also fails because there's no APIs for checking and deleting reviews on the shopping websites. On the other hand, the hybrid agent succeeded because it simplifies the task traces where it utilizes the strengths of both approaches. It first used the API calling approach to retrieve all the product to get the product URL more simply, and then it can use the web browsing approach to go to the product URL that you retrieved from the API calling approach, and then delete all the negative review accordingly from there. This simplifies the task traces, and the hybrid approach succeeded in this case, while the other two approaches both failed. However, there's another case study seeing the different result where the web browsing agent and the hybrid agent both fails and the API calling approach succeeded. This is because that let's see the task. The task is to tell me the email address of the contributor who has the most commits to AI. Where web browsing has a lower success rate on this task because it has very complex traces and could not find all the commits and all the contributors in 15 steps. On the other hand, the API calling approach is very simple. It's only requesting one API call where retrieving all the contributors and retrieving the email of the contributor and find the first email, which will be the contributor with the most number of commits. However, the hybrid agent also fails because it forcefully chose to start with the web browsing approach and did not try to solve the task with the API-based approach. So if its choice to complete the task is incorrect, it will lead to incorrect results. So this might indicate that both approaches have their own strengths and they succeed and fails in different kinds of tasks. As for future directions, we need to first look at the current limitations of the API-based approach and the hybrid approach. First, for the API-based approach, to integrate APIs from websites into the agent, we need to find the APIs ourselves. As I mentioned previously, we need to go to the coordinating websites and download the APIs and provide them as a prompts to API-based agent. And this could be one limitation. Another could be that APIs might not be available immediately, so it might require human efforts to implement the APIs or human efforts to find the APIs online. So to solve this, we are currently working on a project that could automatically induce APIs. So this will not rely on websites' current APIs, but instead, we will use approaches to induce new APIs based on the task itself, and this could solve the limitations that the APIs are not available online or we need to find the API source ourselves. This could enable more generalization towards future incorporation of more other websites into the API-based approach. Yeah, that's all of my presentation. Thank you.